Welcome back to Claymills. In this episode, Jacob and Ethan engage full safety squints. We find out if we can make stuck parts move again after 50 years, and we finally start putting things back together. In this series, we're restoring one of our Lancashire boilers, and it hasn't made steam since 1973. With all the major challenges behind us and a clean bill of health from the boiler inspector, our attention now turns to rebuilding this 90-year-old machine. And there's a laundry list of problems to overcome and things that need to go back together. There are literally parts of this jigsaw all over the site. But we're going to tackle the biggest job first and start putting the brickwork back where it belongs. This all had to be stripped so we could see the condition of the steel beneath. Now it all needs rebuilding, so here's an explanation of where it all goes. A Lancashire boiler sits in a brick cradle that forms the flue passages around the boiler shell. These brick walls guide the hot gases, forcing them to travel the full length of the boiler, not once but twice, extracting as much heat as possible along the way. On the edges of these walls sit 2 rows of seating blocks. These provide even support for the boiler shell, which weighs nearly 20 tonnes when filled with water. At the rear, the central channel continues beyond the shell. This is capped by another brick structure, which seals it to the back of the boiler and forms a chamber known as a plenum. Above the side flues, specially shaped arched bricks close the passages and seal the gas path. An inferno nearly 6 feet long burns at the front of the tubes. If we cut the boiler in half, we can see the route the hot gases take. From the furnace, they travel to the rear of the boiler, down beneath it and back to the front again, where they finally split and travel back along both sides, exiting into the main boiler house flue. We begin by replacing the arch bricks that sit on top of the side flue walls. These form the base for 2 more layers of brickwork above them. Wherever there are rivets on the boiler shell, the bricks have to be carefully cut so they don't touch. As the boiler heats up and cools down, it expands and contracts, and if the bricks rub against the rivet heads, they will slowly wear them away. Above these layers comes a bed of mortar, followed by a layer of slate, and finally everything is capped with large York stone slabs. Before we can start this process on the right hand side though, there is a channel through which the damper shaft runs. This is a clever system that allows airflow through the boiler to be controlled by raising and lowering the damper doors at the rear. Think of this as an accelerator or gas pedal for our American viewers. But for now, we need to get all this moving again. It's been 50 years since this was last used, and all the parts have suffered badly when the boiler house roof was missing. At the moment, it's all seized solid, so we need to find out if any of it can be saved. We may have to strip a lot more of the bricks to fully access this if it needs to be replaced. As we try and preserve as many original parts as possible during our restorations, we spent a day heating all the bearings and feeding them with oil to see if it could be salvaged.
So, there's only 1, 2, 3, 4, 5. Well, there's only 2 exposed. Yeah, there's another one at the back, one at the front.
Most jobs on this old equipment require lots of time and patience, and this one was no exception.
I was going to say, you may as well leave it.
But it's going down that fast.
Yeah.
It's going somewhere now.
Yeah, definitely. You can see it go down.
It's moist on both sides. So.
Yeah.
Okay, it's time to see if we can get it moving.
Are we ready, men?
Yeah.
Go. Can't hear Clive grunting yet. Has anyone got any torsional twisting movement?
That is the most uncomfortable thing to push against, short of a corner. Ankle firm, not moving.
It might just be crushing.
Crushing? What?
Kind. It's sort of, because it's not slipped round.
Is it still round? Unfortunately, the old shaft stubbornly refused to move and started to collapse as we tried, so the only option left was to replace it.
All those hours we wasted warming up that bearing.
something else you've learned.
Well, that's something I never knew at the start of today.
With the old shaft removed and new ends machined to carry the handwheel and sprocket, we could begin rebuilding it. The new ends are fitted using a process called swaging. The pipe is heated until it softens, allowing the new end to be driven into place. These are made slightly oversized so that they form an interference fit. As the pipe cools, it shrinks tightly around the ends, which permanently locks the parts together. The original indicator plate and pointer was salvaged, refurbished, and was then ready to be reinstalled. We started by installing the new damper shaft.
Just move up and down, until, yeah.
There you go. It's start poking out the end now.
Just put a bit further on the key. Just go a bit more if you
A
can.
little bit more.
A bit more. That'll do.
There you go.
See if you can turn that there. Yes, it's the word I'm looking for.
No.
No.
Okay, I can turn it. But there is not enough space for my hands yet.
Yeah, it's going to be alright. It's moving quite freely.
I can turn
It's
it.
quite a big wheel.
We then fitted the chain sprocket and slid in the key that coupled it to the shaft.
Just see where you want the shaft you're in, then we can always smack it on. See
It
where you
fit
want it.
really well earlier, didn't it?
I don't think it matters at that end because it's nowhere near the bed, is it?
No.
Yeah, it's a foot away from the bearing, so you can go what you like.
Oh, perfect. Just give your end a gentle smack if I hold it pulling, see if we can keep it going. We just need to come another half an inch-ish.
With a gentle smacking tool.
Just like that.
Alright, that can be now. Any way you want it. Any way you want it.
Let me move this out here.
With the rear sprocket now fitted, we moved to the other end of the shaft at the boiler front to refit the indicator plate.
So, if I put it on there, well, what direction do they actually go? Is the writing at the bottom? The writing goes down there. Right, if we can get it to start, then hopefully we can send it home with a block of wood.
Oh.
Wait there. Yeah, give it a minute. No, just go.
Down the door.
With the new damper shaft now installed and spinning freely, we can finally put the rest of the brickwork back together. I crawled under the boiler with Toby so that you can see how one of the final seating blocks that he fitted goes into place. Toby spent weeks crawling through these tight passages. About half of the seating blocks beneath this boiler have been removed, because the boiler inspector needed to see all of the areas where the seating blocks met the rivets and joints, in order to make sure that they haven't deteriorated over the last 50 years. It's also been completely cleaned out down here, because all of these passages were filled with inches of ash and soot. The damper shaft was the last major component that needed to be replaced before we put all this brickwork back together, so we can now finally start to complete this project. There were many more days of refitting brickwork and laying these extremely heavy York stone slabs, which doesn't make very interesting viewing, so here's the final slab being refitted. We're going to fit the ash boxes back to the boiler front next. These are solid castings and are extremely heavy. When the boiler's in use, the bottom of the fire tubes catch all the ash that's fallen through the fire grates. This gets raked out, so these boxes catch everything that comes out the bottom of the tubes, so it can be shoveled into wheelbarrows and taken away. These are affixed with 4 bolts to the carrier plate that we fitted last time. Like most parts of this boiler, fitting and aligning these took a bit of work, so we'll show you one in high speed. The other was essentially the same. Here, we're winching the main casting of the right-hand stoker into place. This essentially acts like a funnel, delivering a controlled amount of coal into the combustion chamber. The sprinkler stokers fitted to these boilers are actually older than the boilers themselves, having been carried over from the previous plant on site. Their job is to feed a steady and even supply of coal into the furnace. They are belt driven by the line shafting from above, which powers 2 shafts. The low-speed shaft drives these chevron-shaped paddles which drop a metered amount of coal into the mechanism below. This contains the high-speed shaft which then flicks the coal forward into the furnace. Here, Ethan is fitting the deflector plate. As the stokers were fitted to the boilers over a number of years, they were all slightly different. So although the design is the same, you can't necessarily swap parts between them, so putting them back together often requires adjustment and modification of the components. We do have a stock of original new parts as well, and this casting is one of them. When we removed the original, there was a large crack running through it. We think during the years the boiler house had no roof, this one may have filled with water that then froze and broke the casting. The deflector plate is secured to a pin, which has an arm on it and can be adjusted using this threaded rod, which allows the operator to set the angle. We'll hand over to Jacob and Zach now, who are setting this up.
This is what stops the coal falling straight out the back of it. So this drops in like that over the back.
Yeah.
So you're actually only forcing the coal through a very small hole.
Yeah.
It is all very clever when it's all in and together. I think that. So that's flat out. That's giving it the old 9 yards. Yeah.
Yeah, and it's touching.
And that's-
We'll go all the way up.
It's touching on the sides, as
Yeah.
it should.
Yeah.
Yeah. And then if we come all the way down, that's chucking the old lot on the top of the door. One day we're going to set one of these up with our eyes closed. I'm not quite sure when it's going to be. We've never set one up this carefully before, so this
No, well, we've always gone. This one will be even worse now then.
Yeah, so I'll set that in the middle.
By changing this angle, the operator can control how the coal is thrown into the furnace, allowing it to spread evenly across the firebed. The coal is forced through the small gap beneath this plate, where it meets the vanes on the fast shaft, which flick it into the boiler. So it's the bottom surface of this plate that controls the angle, not the top. We'll jump into high speed now for a few moments, while Ethan and Jacob reinstall the chevrons and slow shaft that feed the coal. Most jobs when you bring something back to life here require hours of adjustment and finessing, and these were no exception. It was a very effective system, which allowed the station to run with remarkably few staff. Even with all this mechanisation, the boiler house was still a very demanding place to work. It was common practice for a single boilerman to work on his own and run 2 boilers for a full 8-hour shift. It was also quite rare for these boilers to be operating side by side. They were used in rotation, with individual units taken out of service for long periods for inspection and maintenance, so it was entirely possible for the 2 boilers in steam to be at opposite ends of the boiler house. We know this because Claymills has detailed archives covering the station's entire working life, from its construction right through to its final day in service. That means we can trace every boiler inspection, every maintenance period, when work was carried out, and exactly what was done. We'll be visiting these in future episodes and telling their stories. We're going to head over to the workshop now, because behind every success at Claymills, there are usually many hours of unseen work. Boiler No.1 was missing both of its furnace doors when we started. So we made new patterns based on the originals and had them cast at a local foundry. The rough castings then have to be machined to their final shape, which means Jacob has spent many hours at the milling machine. So we're taking most of the meat off the sides then of these, yeah?
Yeah, and to most of the depth, but we can't quite get low enough with that one to do the whole lot.
Right.
So we're going to take those to within 20 thou of where we need to be. And then we'll swap to a long series high-speed steel one, like that, just to do the last bit. And obviously we're not really using the end mill in its most efficient side because we're cutting on the edge as opposed to,
Milling on the end,
bottom.
yeah.
Or even on both sides, they self-support a bit better, but when you're using one side,
There's a bit of spring in them, isn't there?
slightly. These solid carbide ones aren't so bad, they're pretty good.
Yeah.
It's lovely.
Thanks to Jacob for that explanation. To give you an idea of how long this has taken, here's a single pass of the mill at 8 times speed. In reality, there are dozens of passes needed on these hinges before they reach their final size. And of course, both doors were missing, so Jacob gets to do all of this twice. Right, we'll head back to the boiler house now, where the next job is to reroute a section of the main water feed pipe. This was installed during the early days of the Claymills restoration, but now it's in the way of refitting the line shafting above Boiler No. 1. The line shafting is driven by the stoker engine and runs overhead along the boiler house. From this shaft, belts are taken down to drive the stokers. Power is transferred into the line shaft through this slip gear, which then drives the long overhead shaft and ultimately powers the stokers themselves. The pipe connects back to the feed pump house, where the original steam engine that supplied the water to the boilers still survives today. I start by removing the old section. It has several unnecessary connections in it, and every joint is a potential leak. When the boilers are in operation, these pipes sit at around £80 per square inch. So whenever we replace sections like this, we try to use continuous lengths of pipe and avoid unnecessary fittings wherever possible. This is 2-inch heavy-walled steel pipe, so the new section has to be formed in our hydraulic pipe bender. After several test fits and multiple trips back and forth to the workshop, we finally get the shape just right. We're another step closer to our end goal, but there's still a way to go before Boiler 1 can make steam again. The final inspection at full steam pressure is now only weeks away. Before we get there, some of the most important parts of the boiler still need to be refitted. In the next episode, we'll be refitting the crown valve. This is the main steam valve that controls all of the steam flow from the boiler, as well as the damper doors which control the airflow, and one of the most important safety systems on this massive machine. Getting this right is absolutely critical if this 90-year-old boiler is going to run again. As always, if you've enjoyed this episode, please consider subscribing. Claymills is run entirely by a charitable trust, and everything you've seen today is the work of volunteers giving up evenings, weekends, and a lot of hard effort to keep this incredible place alive. And with Boiler 1 slowly coming back together, we're one step closer to seeing it back in steam, for the first time in more than 50 years. Join us next time.